Okay, so I started the stream again. Does that mean that it's going to save as a separate video? I really hope so. Otherwise, I just messed it up and I mashed my streams together. Does that link still work? I don't know. Hang on. Am I live for this particular link? No, that one's a dead link now. Okay. Okay, whatever. Jeez. This is a dashboard. How do I get I just want to get the link to my stream. Why is this so hard? Okay, no, I think I figured it out. No, I don't know. Continuation. Right, so it's a different link now. All right, fine, great, fine, whatever. Okay, I got it. I just hear myself now. I gotta pause this thing. All right, continuation, emotion, and CSS and JavaScript. Okay. So the principle of how these things work is they use a library called Stylus, both emotion and styled components and also fancy, under the hood. Stylus is a tiny, maybe about 3 kilobyte, 3 kilobyte CSS compiler that runs client side. And here it is. This is what you're seeing right now. This is styled components, emotion, and so on. This is the thing that allows you to pass in a string that then generates a abstract syntax tree with CSS styles. And they have callback hooks and all that kind of stuff, and that's how emotion and styled components and all that kind of stuff. That's how they generate the unique styles that make up whatever it is your component is. So for example, I'm targeting some class, and I have a font size of something. I'm just going to write pseudocode now. So stylus, I'm just going to call it processor. Stylus is you create an instance of it or something. Again, this is all pseudocode. And processor on generate. There is a plugin system for stylus, and this is how they tap into it. So on generate, do a thing. I don't know, CSS. Okay. So processor, let's say we process this. You have to give it a CSS class name. So in this case, I'll just give it ID, similar to the example. And also we have font size of 2 pixels. Tiny font. Right. So when this happens, every single time a single rule is generated inside of stylus, there is some sort of callback that gets run. And inside the CSS here, this is where the CSS and JavaScript libraries do their magic. And in order for you to understand that a little bit better, I am going to show you what CSS is on the front end, as in terms of how your browser understands it. So when you run or when you execute CSS on the front end, you give your browser a string, right? It's a string with all your styles, and if your styles are written correctly, your browser knows how to parse and compile it and render it into view. So if I take a look at for JavaScript, we have our document object model, which DOM, which is what you see here. So if I do the document, it is this entire gigantic thing, and all the DOM nodes that are associated with your document render inside. There is something very similar, but on the CSS side. So if I do document style sheets here, these are all the .css files that get rendered into your browser when you call link, rel, style sheet, whatever. And here we can see the sources. So for every one of these sources, there is the CSS equivalent of a DOM, but for the style sheet object model. And you can see them all inside of CSS rules. Hang on, I gotta find one that actually compiles to something. No. So far I'm doing a really bad job. There we go, rules. So this one, we can see this is like some sort of font thing that has font rules inside. Let's find something a little bit more interesting. Where am I? I'm on NPM. Oh, okay. Those rules are okay. Those rules are not as interesting. Why are there so few rules? There has to be way more. Anyway, it's fine. It's fine. So if we take a look at this particular bit of CSS, we can see that there's a rule for .marketing, and this is the AST for a single CSS rule. We have the text. This is the original single rule that you gave the CSS engine to parse. And then it recognizes what the selector is. In this case, it's a class named marketing. And then it generates all the styles via this object, I suppose. Yeah, it's like a set or something, a hash table or something that has all the key value pairs for the CSS. In this case, we are changing the margin, the padding, the font size, and so on. So if I take a look at this object, padding, we'll go all the way down to padding. You'll see that it's 0.7 because the original rule told it to be 0.7. This is what CSS is in the browser. So when you go to do something like window get computed style for a particular DOM node, it's referencing this. The style object you get back is a computed something of all these styles mashed together, depending on what match. And this is what CSS is. And this is really important because this is the foundation for how something like stylus works. It creates an AST, and then it exposes that particular rule for every single rule that you get, and then you do something with it. So for styled emotion, I'm just going to say emotion from now on. And by emotion, I mean styled components and emotion. So for emotion, and fancy. So for emotion, how it works is there's several mechanisms that allow this thing to work. The very important one is the compiler, which is stylus. The other one is a cache. And the other one is, I guess, the interpreter. If I can spell. I spelled this wrong. Probably did. Give me a second. Oh no, it's correct. Okay. So we have the interpreter with this compiler, interpreter / parser. We have the compiler, we have the cache. So when you run styled div and then you pass it a string, this first goes into a parser or an interpreter. And this is really important because if you were to, in addition to writing this, you can do string interpolation, and this allows you to tap into properties that you passed into this particular component. So if I called this like a hello component, and I gave it I don't know, props background. And this is just regular JavaScript at this point. So if I do something like this, and I know this syntax looks very strange compared to what you might be used to. Welcome to the world of CSS and JavaScript, where you're literally writing JavaScript inside of CSS. So now when I create a hello component and I give it a property of background, purple, when this renders and this gets compiled, instead of being red, the background will be dynamically injected here, depending on what I passed the property to the component itself. CSS compiler. So how it does that is this is all. By the way, this template literal string thing, I forget what it's called. Template string literal, or I don't know. It's a very complex name. Template strings. Yeah, sure. This thing. This is vanilla JavaScript. This is inside of ESX. This is normal. You get this out of the box, and with it, you get to do very interesting techniques. So how this works is, it basically becomes an array that gets passed into this particular function. And the array is broken up every single time you have a function mixed with a string. So the first chunk of the array is, I believe it's a background red. And the second chunk is a function. And if you had additional styles like, I don't know, color blue, it'd go like this. I might be getting the order of some of these things wrong, but overall, this is the kind of principle of how this works. So once this gets passed into this particular very special function, it's up to this guy to understand how to render a string based on this. So there's basically a reducer that happens that loops through all these guys to accumulate a string. And every single time a function is called, it will execute that function by passing in. So here we have to get the property somehow from when you do something like this. Background is purple. So this particular function needs to be able to get to access this. By this, I mean the properties. So when you instantiate this styled, which is a function, this is basically a React component. So you get access to props. And then somehow you get access to all the args that come afterwards. Again, okay, so this is pseudocode just to kind of illustrate the example. So it knows about how, we'll go into the code after this. This is like a higher order component that does prop passing around. But anyway, it knows about the properties, and it somehow gets the args here. So when this reduces down, every single time a function gets called, this props object gets passed into that function in order for that particular function to compute. And once it's done doing all that kind of stuff, you now have your parsed, flattened string that hopefully is compatible with the compiler, which is Stylus. So now we have our generated string, which might look like this. Background, from the previous example, it was red, but with the props that we defined, it was now background purple. Okay? And the other thing that we declared when we created a styled component is the tag. And the tag we said was div. So when it gets passed to the compiler, Stylus, here, you see that you have to give it a class name and then the styles that you want bound to that particular selector. Sorry, not class name, selector. So it's up to the CSS in JavaScript library to determine what this class name is. So it knows that you want to generate a div. This is not important to Stylus. This is only important to the React part, because here we have the React create element, div, and then you give it properties. So that's what this div is for. So we need to somehow generate the CSS or mashup hashed class name that gets rendered into Stylus. So that's where the cache comes in. It'll check to see, here's how it works. Okay. So starting off, the cache is basically a normal, it's either a map or a set. By map, I mean one of these versus a new set. One of those, where you have this computed style like this. That is essentially stored as, I guess it could be a key inside of your map, like that. And the value of this is some sort of CSS name, right? Like that. So this is like the first time this style gets generated, it gets added to the map, and then some sort of random hash gets associated as a value. So when this happens, now we're ready. And by this, and with this, like, it'll just generate anything. I don't know what particular UUID generator hash thing that they use. You can just use anything to generate some sort of hash. So now when it gets put into the compiler, it will say stylus and this guy, hey stylus, please generate for me this style, please. Okay. Okay. And then stylus will then eventually output CSS. So why is this important? Why does it need to get passed through stylus to begin with if I've already interpreted this string here? That's because this could contain CSS that's not compatible with vanilla CSS. So for example, ampersand, hover, that needs to get compiled down. Media queries need to get compiled down. And the other thing that stylus does for you, which is really nice, is it does vendor prefixing for you, which is why people fell in love with post CSS to begin with, because it automatically did vendor prefixing. So if you did something like transform, translate, blah, 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 when stylus compiles it, you actually get the WebKit transform and the Moz transform and all that stuff. So that's really nice. So it still needs to go through our CSS compiler. And once that's done, the output code might look the same. It's fine. Looks like that. And what happens now, there's actually another step. I'm just going to call this the renderer. So what happens now is the emotion does something that looks like this. I'm just going to Google this in case I forget the API. Document, JavaScript, document, create rule, style sheet rule. Yes, here we go. This is it. I forget. This is like an arbitrary random thing. I forget how it works. Okay. Okay. This is very, very complicated logic or example, but what this is basically how this gets rendered into the browser is emotion will create a style tag as its main anchor point. So do something like document, create element, style, and then this will get injected into the DOM. And it'll keep a reference of this on style tag somewhere in its memory. So once this particular style gets rendered out, we know the selector, and we know the final compiled style that we want emotion to render, or sorry, that we want to be rendered into the DOM. And we know the target style tag, which is this guy, there. So once all that is done, we are going to inject or insert the rule into the style tag. It does something here. Yeah, basically this. You target your style sheet, which is this guy. It's not that this guy exactly. There's this document object. This DOM element is special. You have a .sheet object, so you get the .sheet object. You insert the rule. You have the selector, which is this. Sorry, dot that, and then you have the rule, which is here. And then you insert it as a specific index. And the simplest way is to increment that index by 1 every single time you have a new rule. This index is important though, so we have to somehow cache that or remember that as well. I'm just going to call that sheet Style index is fine. 1. Okay? So there it is. This is how emotion works. We interpret whatever it is your original styled thing was to make sure that it's compatible with the compiler. We run it through the compiler, we add it to the cache. Once we add it to the cache, we render it out. So that's how you create a single style on the initial run. What about subsequent runs? Okay, so let's say your particular styled components gets referred to or rendered again. This particular guy. Because we have the cache, and because we have this cache, we basically compare whatever it is styleless outputs to what's available in the cache. If it's there, then we'll just give you the same CSS rule again. Because it's exactly the same, this saves emotion from generating a new rule. And then the flow goes as normal. If there's no difference, then it doesn't really output anything, and we're fine. So this pattern is very, very familiar for those of you who've already done React. This is basically that DOM. In React, you have a VDOM, virtual DOM diffing between the real DOM and the virtual DOM, and if there's a difference, render it out. This is the same pattern we have, but for the CSS compiler side, where we have a cached version, a virtual version of the style sheet, and then we have the actual style sheet somewhere that we need to render out. When you have new styles, we'll compare it with the virtual style sheet. If it's different, we'll add a new style rule and we'll render it out. If it's not different, we won't do anything. We'll just serve you the existing one. And I thought that was a very interesting pattern. That's how styled components and emotion works. The other interesting thing is in styled components and emotion, you are able to extend existing styled components. So if I had a const A is styled, no, I'm going to give them proper names. Let's go with fruits. Apple is styled. It's a div. Yeah, apple's a good one. Yeah, background, red. And if I had a const banana, I'm going to do this a little bit better. Padding is 20. Banana is a styled, it's a styled apple because why not? And the color, the background is now yellow. We're just going to delete all this. So for this to happen, the styles that we expect banana to be is, it has to have a background of yellow, and it has to have a padding of 20. It extends or absorbs, or I don't know. It gets this style because you passed in a already computed styled component thing as banana for it to extend. So in order for styled components to do this, again, it refers to the cache of what this particular style is. So let's say we have that as a thing. Whoops, and then we'll just, for simplicity, I'll just say A. So it checks the cache, and they'll be like, oh, this already exists. I'm going to extend this for you, and I'm going to combine this style to create, which eventually gets computed to something that looks like this. We'll call this CSS-B. So that is how styled components is able to extend existing styles to generate new ones. It refers to the cache. The cache is very important, and then it does things to generate new styles if applicable or not. This really simplifies how it works, but this is the principle of how it works. There is another performance mechanism built into it where if for some reason this guy is updated, because maybe you have some dynamic stuff going on where it's like props equals, whatever, and then your background thing is dynamically generated. Background props background. So on the initial call of the compiler, this runs out. This generates. On the subsequent call, I mean, let's pretend this is a color picker, and then the user is like color picking all over the place. You would then have a bunch of styles that get rendered like this. So I can't confirm if this is what happens in production, but in dev, you'll see this happening. If you open up something that's running style emotion 9, you will see tons of style tags inside of your document head. That's because all these styles are getting computed out. In production, this does not happen. They consolidate everything for you and it's cached correctly. So I think what happens is, on subsequent runs, if it knows that it's the same object, it will, instead of generating brand new styles, it will change the value of this to whatever it is you need. And then the class then changes. I can't confirm, but I think that's kind of how it works. And remember before, when we inserted the style sheet, we needed the target selector, which now is CSS-B. We have the styles, which is this. And then lastly, we needed the index. So if it knew where the index was originally, when it inserted the style, we can insert this exact same style rule at that exact same index, and that'll override what's existing in the CSS Object Model index, which prevents us from writing additional styles. We're just updating the value of the current one. And yeah, that's how it extends styles. Pretty interesting stuff. So what's there left to go over? Oh yeah, theming. All right. So we basically went over the concept of these particular libraries that power emotion. We have create emotion. We have the style that takes care of all that nonsense, compile-y, transpile-y, parser bits. So now we're at the level of providers. So in styled emotion, give me a second. I'm going to take a break. Oh wow, they changed their docs. This looks nice. How did they render this? This Gatsby? Yes, it is. Gatsby's pretty fun. Algolia, fun. I really got to get onto this Algolia thing. It's really cool. Interesting. It's a separate library now. Okay, so inside of emotion, you can do theming, where if you provide your theme provider with some sort of value, any styled components that get rendered within know how to communicate to it, and therefore knows how to adjust their styles based on the theme that you provided. So in this case, the some text component knows how to change itself to hot pink because that's the theme you gave it. And how that works is, at least for fancy and styled for emotion number 9. I like that. We call it emotion number 9. So emotion number 9 and fancy. How it works is there is an internal broadcast pub sub system that goes on. I can demonstrate that with frame provider. Right. Create broadcast. This is not helpful right now. Right. So this is basically a pub sub system that gets generated. When your provider gets created, the pub sub gets generated on mount, and then component will mount. Wow. I haven't seen that in a while. Yeah, it gets generated before the component mounts, and when it mounts, it tells anything listening to it that, hey, I'm ready. And then it exposes the subscribe and the unsubscribe methods to child components available via context. This is the older context API that you're seeing right here. And that's it. That's all it does. And the thing that it's trying to give the context is, at least for frame provider is the document, the frame that the document that the styles need to generate into. Because earlier I said that there is a CSS Object Model, which is available via document. I forget this. Style sheets? Yeah. Document style sheets. So this is the thing, the CSS Object Model, that styled components and emotions and all that kind of stuff need to generate into. But they need to know which document you're talking about. So if you're rendering things within an iframe, you need to reference the iframes document. So that's what the frame provider does. It figures out what the correct document is, and it provides that to all the consumers of frame provider. So theme provider does a very similar thing, except it's way more simpler, where in the beginning, where you would say what your theme is here, like that. It sets up a pub sub, and then when it renders, it'll then publish and publishes that theme object to the consuming components. And that consuming component, like, this is emotion 10 docs, by the way, so it's a little bit different. I apologize. The consuming thing will then know what the theme is in order for it to compute the styles accordingly. And based on that principle, scope provider and frame provider works exactly the same way. I needed to modify create emotion styled in order for it to understand how to work with those new mechanisms. Frame manager? No. Frame channel. Oh gosh. So the majority of what you're seeing here, this is emotion 9. I didn't write this. I only modified some things in order to make all this kind of stuff happen, plus add a little, some enhancements here and there. So when this is about to mount, this is where it happens. The subscription for both the theme and also the frame provider here. Yeah, so we subscribe to the providers, and then we manipulate what the final styles are going to be in this gigantic render method that does a lot of complicated things with a lot of checks and a lot of logic and does whatever. Again, I didn't write this. This is emotion number 9 out of the box. I just enhanced it a bit. That's how it works. This is how emotion works. We have the 4 main things, which are the parser, we have the compiler, we have the cache, and we have the renderer. And then we have the actual React component itself that handles things and knows which document to inject things into, and handles the handoff of document, scope, and theme to the parser and compiler. And the last bit is server-side rendered styles. How does it know how to do that? Well, once we understand all these mechanisms, it's pretty simple. So the thing that you can do with emotion is you are able to server-side rendering. You're able to render all the styles that it has to a single string, and that string can then get generated into your server-side rendered application as as a gigantic style tag, and that's how you server-side render your emotion styles. So how does it work? Well, remember that cache that we talked about? That virtual style sheet where all the styles are? It basically flattens all that to a single string, and that string is a thing that you pass into your server-side rendered application, and that's how you server-side render styles. Pretty simple. So yeah, this has been a extremely deep dive into Fancy, or into all the mechanisms that make up Fancy. Let me see. So we talked about style. This is the processor, the compiler, essentially, that runs client side to parse all the styles that you need for emotion. We talked about how iframe theming and scoping works in terms of how those settings from the provider works with the consumer of the styled components. We talked about how your styles get interpreted from here into the compiler, into the cache, and then how that cache then renders into the DOM, or the document, via the CSS Object Model. And we talked about how extending and I guess I don't want to say DOM diffing. CSS Object Model diffing works for performance to figure out when and where styles need to update and render. And also touched a little bit upon server-side rendering, taking the cache, flattening it out into a string, and then passing it into your server-side rendered application. And yeah, that's it. Now you know everything that you need to know about CSS and JavaScript in Fancy. And you probably never want to think about CSS object models or anything again, because it's very heavy stuff. So hopefully you found this entertaining, useful. If not, I apologize. And I hope you have a great day. Bye.